let's try to solve another Leetcode problem. 1594, maximum non-negative product in a matrix. So for this problem, we are given a matrix and we're gonna return the maximum non-negative product modulo this number. So if the maximum product is negative, so we're gonna return a -1. And we should also notice that the modulo is performed after getting the maximum product. So this means after getting the final result, if it is a negative value, so we're gonna return a -1. So in this example, maybe it is a negative value, so we're gonna return a -1. But if it is a positive value, so we're gonna return this value modular this mod. Yeah, so this is the mod. So if it is a positive value or if it is a 0, so we're gonna modular 10 to the power of 9 plus 7. So inside of the matrix, there can be positive number or it can be negative number. Yeah, so normally for such kind of problem, if we are given a matrix and we want to return the maximum non-negative product or some value, it means we need to have the multiplication of all those values inside of the matrix. So for example, this 1, 1, -2, -4, and 1. It's going to be something like that. Let's just prepare some cases. Maybe it is helpful for us to understand the problem. So for the last value at this areas, maybe the last value can be a -2 in this example, or it can be a positive value. For example, it can be a positive 2 or it can be a -2. And the value just above it. So for example, it can be a -20 or it can be a 20. And at its left side, it can be a -30 or it can be 30. So what's going to be the possible result? So if we choose this number 2, so if it is a number 2, so we're going to choose this number 30 because 30 is more than 20. So the maximum result is going to be 60. But what if this number is -2? So if it is a -2, we're going to choose the minimum value of the 2. Maybe the minimum value for this one is -20 and this is -30. So we're going to choose -30. So if it is -30 times -2, it's going to still be 60. Yeah. So this means we need to analyze it by using two cases. Basically, we're going to use 2 DP. We're going to use a maximum DP and a minimum DP. So inside the maximum DP 2D array, we're going to store the values which is going to be the maximum value. And inside of the minimum DP array, we're going to store the values which is going to be the minimum value. So for example, inside of the maximum DP array, we're going to store values like 20 and 30. And here we're going to store values like 60. This is going to be the final result. Yeah. And inside of the minimum array, so this is going to be the minimum DP array, we're going to store values like -20 or -30. Yeah, so the value is going to be like this. Yeah. So now, but for the last one, this is going to be the final result. We need to check it by using the maximum DP array because this one stores the maximum value. Yeah. Now let's just start coding. We're going to prepare R and C. It's going to be length of the grid and the length of the grid 0. And the mod is going to be 10 to the power of 9 plus 7. And first of all, let's just prepare a maximum and minimum DP array. So it's going to be equal to yeah, so we're going to use a deep copy with this grid. So first of all, we're going to deep copy it. So currently this maximum and minimum array going to equal to this DP copy, going to equal to this grid. Yeah, I'm not sure if this is totally okay. Maybe currently I need to write it like this. Yeah, because basically I need 2 copies. I cannot use the reference for them. Yeah, so this is the maximum DP array, and this is the minimum DP array. It will have another copy of the grid. So this is just the deep copy because it is a 2D array. We cannot use a just copy. Yeah, because a copy is just for 1D array. This is a 2D array. We need to copy all of them. So we're going to use a deep copy. Now let's just check the easy case. So for R in range from 1 to R. So this means we're going to check the first column. So for the first column, because there's only one direction, we just need to use multiplication for all those values. So we're gonna prepare the maximum with R0 gonna equal to the minimum of R0. Yeah. So this value gonna equal to, yeah, we can just choose the maximum or minimum. It is okay because it's the same value. It's gonna be R minus 1 0 times grade R0. So this is gonna be the yeah, so this is going to be the preparation for the first column. Now let's just prepare the first row as well. So it's going to be for C in range 1 to capital C. So here going to be 0 C, and here going to be 0 C, and this one going to be 0 C minus 1. And for the grade, similarly, it's going to be grade 0C. Yeah. So after the preparation, we can start the DP. So for R in range from 1 to capital R, and for C in range from 1 to capital C. So this is just for the case like that. From here, it can be a positive value, or it can be a negative value. And from here, it can be a 20, or it can be a negative 20. And here it can be a 30 or negative 30. Yeah. So this is for the final case. So let's just check that. And we need to check the grade R and C. So if the grade R and C is more than or equal to 0, basically this means if my current value is a positive value. So for example, my current value is a positive value. It is 2. So it means I need to check the maximum DP array. So I need to update the maximum of R and C. So it's going to be equal to the maximum of DP array with R minus 1 C, and the maximum of R C minus 1. And why we choose the maximum value? Because it is a product. So we need to use the maximum of the two values times the grade R and C. But we don't need to use the modular yet. Yeah, because here we need to use the polynomial after getting the maximum product. But from here, we didn't get the maximum product yet. We just need to get it from the final return. So it means from here, we don't need to do the modular. And similarly, we can also prepare the minimum DP array. So the minimum DP array, we just need to change it to the minimum. So from here, we're going to use the minimum, and let's just change it to the minimum. Yeah. Now this is for the case if the grade R and C more than 0, more than or equal to 0. But if it is a negative value, yeah. So let's just copy it. So if this is a negative value, for example, if it is a negative 2, it means the maximum value going to be chosen from the minimum value. It's going to be this negative 30. Yeah. So here we're going to choose the minimum value. So this is the maximum R and C. So it's going to be the minimum of the two values. So this one going to be the minimum, and here going to be the minimum as well, and times grade R and C. And for the minimum R and C, actually it's going to be the maximum. Yeah. So for example, from here, the minimum value going to be this minus 2 times 30. It's going to be the negative 60. It's going to be the minimum value. So this is why we're going to choose it from the maximum array. So we just need to change it to the maximum DP array. Now I think we finished all the calculation, and we just need to return the final result. It's going to be coming from the maximum DP array. It's going to be the negative 1 and the negative 1 modular mod. So if this value is more than or equal to 0, otherwise we're going to return a negative 1. I think there's a lot of coding. Basically we need to check it carefully, and otherwise we're going to make mistakes. Let me just make a run to check if it works. As you can see, it works. Now let me just submit it to check if it can pass. As you can see, it passed all testing cases and it's pretty fast, and the time complexity is just R times C. Actually, it's going to be from here, it's going to be 15 times 15. That is why it is so fast. And for such problem, I think we just need to read the problem carefully. The modular should be the final return. We cannot modular from here, otherwise we're going to make mistakes. And also we need to be careful with the grid R and C. It can be positive value and it can be negative value. Basically, we need to make such kind of a drawing. If we can prepare such kind of a drawing, we knew that we should use a 2 DP array, the minimum DP array and maximum DP array, and then we're going to use 2 DP array and just use some mathematics skills to solve the problem. I think that's all about it. Thank you for watching. See you next time.